Exploring the Origins of Elements in the Universe. Title: Exploring the Origins of Elements in the Universe. Introduction. The universe, a vast expanse of mystery and wonder, is made up of a wide variety of elements. From the brilliant stars that dot the night sky to the very atoms that make up our bodies, these elements form the building blocks of everything around us. But have you ever wondered where these elements come from? Join us on a journey as we delve into the origins of elements in the universe, exploring the birthplaces of these fundamental substances. The Big Bang and the primordial elements. Our journey begins with the Big Bang, the event that marked the birth of the universe as we know it. Around 13.8 billion years ago, a hot and dense singularity exploded, releasing an immense amount of energy and matter into the cosmos. In the immediate aftermath of the Big Bang, the universe was incredibly hot and dense, consisting primarily of neutrons, protons, and electrons. As the universe expanded and cooled, these subatomic particles began to come together to form the first atomic nuclei. This period, known as nucleosynthesis, lasted for a few minutes and led to the creation of the primordial elements, primarily hydrogen and helium with trace amounts of lithium. Stellar nucleosynthesis, the crucible of creation. While the primordial elements play a crucial role in the composition of the universe, the vast array of elements we observe today requires additional processes. One of the most significant contributors to the formation of elements is stellar nucleosynthesis, which occurs within the hearts of stars. Stars, the celestial furnaces that dot the cosmos, are formed from massive clouds of gas and dust. As these clouds collapse under the force of gravity, they ignite, and nuclear fusion reactions begin. The immense temperatures and pressures in stellar cores facilitate the fusion of lighter elements into heavier ones. The hydrogen found in stars undergoes fusion reactions, converting it into helium. This process liberates vast amounts of energy, powering the star and preventing gravitational collapse. Stars spend most of their lives fusing hydrogen into helium until they exhaust their hydrogen fuel. As stars age and evolve, they undergo a series of fusion reactions involving increasingly heavier elements. The helium produced in stellar cores becomes the fuel for further fusion, leading to the creation of carbon, oxygen, and other elements up to iron. This process is vital in supplying the universe with heavier elements, but it only accounts for elements up to iron's atomic number. Supernovae, the explosive birth of elements. The life cycles of stars ultimately culminate in spectacular explosions known as supernovae. These cataclysmic events release an extraordinary amount of energy, outshining entire galaxies for brief moments. Yet, supernovae are not just cosmic light shows, they are also the primary source for elements beyond iron in abundance. During a supernova, an enormous shockwave sweeps through the star, compressing the matter to extreme densities and temperatures. This compression triggers rapid nuclear reactions, resulting in the synthesis of a wide range of elements. Elements like gold, platinum, and uranium owe their existence to the intense conditions within these stellar explosions. Furthermore, the violent explosion of a supernova propels these newly formed elements back into space, scattering them throughout the cosmos. These ejected elements mix with interstellar clouds, becoming the raw materials for future generations of stars and planetary systems. Cosmic ray spallation and cosmic dust. Another mechanism responsible for the generation of elements in the universe is cosmic ray spallation. Cosmic rays, highly energetic particles originating from various astrophysical sources, collide with interstellar matter, breaking apart existing atomic nuclei and creating new elements. The process of cosmic ray spallation plays a crucial role in the production of light elements such as lithium, beryllium, and boron. These elements are synthesized through interactions between cosmic rays and interstellar gas, further enriching the elemental diversity within our galaxy. Additionally, cosmic dust particles, composed of various minerals and elements, play a vital role in the chemical evolution of galaxies. These tiny particles act as catalysts, facilitating chemical reactions necessary for the formation of complex molecules, including organic compounds. As they journey through space, cosmic dust grains serve as repositories for elements, transporting them across different regions of the universe. The formation of planetary systems. While the creation of elements is a fascinating aspect of cosmic evolution, it is equally important to understand how these elements come together to form planetary systems. Planets, moons, asteroids, and comets are all part of the intricate dance of gravity and astrophysical processes. Planetary systems are born from the remnants of previous generations of stars. When a massive star reaches the end of its life and undergoes a supernova explosion, it releases a shockwave that compresses nearby interstellar clouds. These compressed regions become nurseries for new stars and planetary systems. Within these molecular clouds, the enriched elements from previous generations of stars come together to form protoplanetary disks. These disks consist of gas and dust particles that slowly clump together due to gravitational attraction. Over time, these clumps grow larger and larger, eventually forming planetesimals, small bodies that serve as the building blocks of planets. Through a process known as accretion, these planetesimals collide and merge, gradually forming planets. The composition of these planets is highly influenced by the elements available in the protoplanetary disk. Inner planets, like Earth, tend to be rocky and primarily composed of elements such as silicon, oxygen, iron, and magnesium. Outer gas giants, like Jupiter and Saturn, have a significant amount of hydrogen and helium. As the planet formation process continues, smaller bodies like moons, asteroids, and comets also come into existence. Moons are formed when the gravitational pull of a planet captures smaller objects in its vicinity. Asteroids and comets, on the other hand, can be remnants from the early stages of the solar system or objects that were ejected from other regions. Exploring exoplanets, expanding our understanding. In recent years, the study of exoplanets, planets outside our solar system, has significantly expanded our understanding of planetary formation and the presence of elements in the universe.